Okay, so we've got these four coplanar forces here of different magnitudes acting on a particle P, okay, and the particle P has got mass 5 kilograms in the directions then shown. So we need to find the magnitude of the resultant force and determine the angle it makes with the 85 Newton force. So first things first, we're going to resolve forces in the x and y direction. Okay, so we do our cross. And we must remember, this is so important, that all of this is happening on a horizontal plane, yeah? Because they say there, don't they, the four coplanar horizontal forces. So every one of these forces are horizontal. As if now we are looking down on it, we are in the sky, we're looking down, and all of this is happening on the ground. So you've got 60 newtons pulling in that direction, 75 newtons in this direction, 85 in that, and so on. So it's important to realise now that doesn't mean up, right? So that's not up and this isn't down. Okay, it's all happening on the ground as if it's like a tug of war in four directions, and we're all pulling in those different paths there. So we just simply then apply then these forces, resolve them. So we've got 60 newtons going in the x positive y direction then. We've got 85 then in the positive x, 40 in the sort of negative x direction. And then with the 75, of course, then, because the angle is contained there, it'll be 75 cos alpha that way, and 75 sine alpha then opposing it. Okay. Now, these are not in equilibrium, okay, so it's moving. So quite simply then, we need to resolve, and first of all, maybe we'll resolve in the x direction. So if we take this as positive, so we've got 85 plus 75 cos alpha, take away then the opposing force, which is 40, okay? Now, of course, then we need to work out what cos alpha is. So if we go back to the start here, it says tan alpha is 3/4. Now remember, tan alpha, okay, is opposite over adjacent, isn't it? Okay, TOA, so opposite over adjacent, so that's 3/4. So if I were to draw a right angle triangle, okay, then the opposite, if that was angle alpha, the opposite then would be here, which is 3, because 3 on top, and the adjacent then on the bottom 4, the adjacent is this side, so that'll be 4. And then you can work out what the hypotenuse is here, okay? Now this is, of course, we know this is the 3, 4, 5 triangle, okay? But of course you could use Pythagoras to prove that, so you do 4 squared, add 3 squared, square root it, and you get 5 there, yeah? Now of course then, with that, once you've got that, we can work out what cos alpha is. In this case, so cos alpha will be adjacent over hypotenuse, so 4 over 5. So 85 plus 75 times 4/5, take away 40. So if I work that out on my calculator, and I get 105. So it's positive 105 there, so it is acting to the right. And then if I resolve then in the y direction, so I've got 60 in the positive y, take away then 75 sine alpha. So on the next line then, that would be 60 take away 75, or sine alpha. We go back up to this triangle, sine alpha is opposite over hypotenuse, 3 over 5, so 3/5. So I get 60 take away 75 times 3/5, and that comes out to be 15. Okay, so 15 Newton. So if we see now my overall resultant effect, I've got 105 going to the right and 15 then going in the positive y. Okay, so so essentially I've got my resultant is going to be yeah, what was it, 105 this way and 15 this way. Okay, so then the resultant then, the overall effect, of course, because it's going across a lot and then going in the y direction a little bit, essentially it's going to move sort of roughly in that direction there, yeah? That's my resultant, and my angle then to the force that they want will be theta here. So I can work out R. So remember, to work out the resultant, you just got to apply Pythagoras. So just appreciate now it's 105 across. In the x direction, 15 in the y direction, And then r then will be the hypotenuse. So if you do r then is, well, 105 squared. You square this side, add them, and then square root. So r will be 75 root 2. So r will be 106.066 newtons. Okay, and then to get the angle then, theta then will be this angle here. Okay, so that will be tan theta opposite over adjacent. So 15 upon 105, which will be, and then theta then will be tan to the minus 1, or 15 over 105, which will be 8.13 degrees. Okay, so that's the angle there that it makes with, because it originally said 85 Newton force, isn't it? So it's with the extraction there, and that's exactly what I worked out there. So 8.13 degrees. Now, finally, then with part B, it says deduce the magnitude of the acceleration of the particle P. So we're talking about the acceleration, and then of course we're going to apply Newton's second law. Now, we know the resultant force is equal to 75 root 2 newtons. We established that there. So then applying Newton's second law, so the resultant force, okay, F is equal to mass times acceleration. So we got 75 root 2. The mass of the object, if you go back to the start, was 5 times A. So using Newton's second law, divide through by 5 then, so you get 15 root 2 is equal to A. Okay, so that's your acceleration. So we could work that out in decimal form as well. So we get 21.2 meters per second squared. Okay.